this one right here. So that's the adjacent part of the triangle, so that's actually cosine. The FG perpendicular is just FG cosine theta, which is just 50 newtons cosine of 18.8 degrees, which comes out to, let's see here, 18.8 cosine times 50, it's almost 50. Comes out to about 47 newtons. Now, the normal force's job is to balance that FG perpendicular in this case, and so it too is 47 newtons. You may have remembered normal force from way back in the day. I actually taught you Fn was Fg cos theta. Really, Fn is just balancing the Fg perpendicular here. Fg perpendicular is Fg cos theta. So if you did remember this, it can help you. Alright, let's get the Fg parallel over here. So, Fg parallel is going to be Fg sine theta, which is 50 newtons times the sine of 18.8 degrees, which comes out to, this will be much smaller, 18.8 sine times 50, it's about a third of it. This one's about 16 newtons. Okay, cool. We're getting somewhere, So look at all these forces we now have. We have Fg, we have its two components that line up parallel to the motion and perpendicular to the motion, 16 and 47 newtons. We got the pull of 20, we got the normal 47, we got the F net 0. Is this an F net 0 picture? Currently the answer to that is no. In the perpendicular to ramp direction, yes, these cancel out. But in the parallel, they do not. We have 20 newtons up and 16 newtons down. We're missing something. What are we missing? Friction. There's another, not a particularly big force. There's another frictional force pointing down the ramp. And that frictional force, along with the Fg parallel, have to balance out the pull. So 16 plus x is 20. This is just a 4 Newton frictional force. Now we've got all of our forces in here. Fantastic. Alright, time to do the work. Alright. So, the easiest one to do right now, any force that's perpendicular to the displacement does no work. So right away, let's write it over here. The work done by the normal force, it's going to be Fn d cosine 90, 0 joules. Done. Fg perpendicular does no work, but the Fg parallel does. So we can do Wg is going to be Fg parallel d. Notice that they line up. Actually anti-align. This is actually cosine theta. It's actually cosine 180, so you're going to get a negative in there. So you're going to get 16 newtons times 5.6 meters times the cosine of 180, and that comes out to 16 times 5.6, about 89.6 newtons. So we can keep it easy. There's a negative in there. Well, it's about negative 90. Sorry, newtons. My mistake. Joules. This is work. Negative 90 joules. Okay. I'll show you there are a couple other ways to do this. We'll look at that in a minute. The external force over here does some work. Work external is going to be F external D. You don't need the cosine here because these two line up exactly. It's cos 0, which is just 1. So 20 newtons times 5.60 meters is, let's see, what's 2 times 5.6? 11.2, so 112 joules of work done by that force. The frictional force we should be able to figure out by subtraction, but let's do the math. FFD, so 4 newtons times 5.60 meters, and this one technically is cosine 180, so the frictional comes out to 4 times 5.6, 22, negative 22.4 joules. Remember, we got some rounding built into these, so we had a 0.6 over here. Alright, so there we go. And if we rounded this to just 2 sig figs, we have negative 22 joules. Alright, cool. And of course, net force is 0, so the work net will come come out to 0 joules as well. Just to check in with the work net, the other way to do it, of course, is to add up the works. So we had 112 joules of work from the external force. We had negative 22 joules of work done against friction, and negative 90 joules of work done against gravity. These two together is negative 112, positive 112. This comes out to 0, as it should. Now, for those of you who would like to see alternates, I've written this up in the notes and the solutions to homeworks we did before we were out of school. And more than one way to skin the gravity cat. You could have done this with a couple of ways here. You could have done the WG alternates for WG. You could have done WG equals FGD, and instead of lining up, look what we did over here, we lined up the component of force with the displacement, or anti-aligned it. We can instead align the component of displacement with the force. What do I mean there? FG is pointing down, 50 newtons. Is the displacement vertical at all? Well, yeah, it is. This amount, 1.8. So another way to do this would actually be 50 newtons times 1.8 meters times cosine of 180, because down and the displacement here is actually up. And interestingly enough, you will get negative 90 joules, just as we did before. This makes sense. Look at that. There's even a second alternate here. If you really just like getting crazy with FD cosine theta, so there's one alternate. Here's another. W equals FGD cosine theta. And you know what? Don't worry about the components at all. This is WG. So WG equals, FG is 50 newtons. Cool. Displacement is 5.60 meters. Cool. Cosine, what's the angle between them? Well, that one takes a little thinking up here. FG is down. Displacement is up this way. In fact, it's up this way, inclined 30 degrees to horizontal. So from this angle to this vector to this vector, this full angle, that's the displacement also, points this way. This full angle is actually 30 plus 90, which is 120 degrees. Now you can do your reference angles if you want, or you can just punch this whole thing into your calculator. 120, which you may want to do, cosine, gives you that negative 0.5 times 50 times 5.6. Let's see here. Let me pause you on that one a minute. Was it a... Oh! There's my issue. I'm looking at the math and saying this didn't work. What did I do wrong? Sorry. It's not a 30-degree angle. Those of this along. It's an 18.8 degree angle. That's why the math wasn't working. So it's 90 plus 18.8. That's 108.8 degrees. Sorry about that. 108.8 cosine times 5.6 times 50, and boom, you get, once again, negative 90 joules. Look at that. More than one way to skin a cat. Alright, so use these skills to do skill drill questions 4 through 6 on the homework for Thursday, due on Thursday. Beware on those, sliding into home plate, falling freely from rest, and accelerating. Those three scenarios, don't expect your F net to automatically be 0, because it may not.